What's going on, everybody? Welcome back to my YouTube channel, where we have this question on the board which says find the value of x for which the square root of 2 minus the square root of 2 plus x is equal to x. Well, I'm going to be applying a trick to solve this question. And what is that trick? Well, it is by replacing this 2 here. Since I have 2 and I also have 2 here, I'm going to be replacing this 2 by a variable, let's say p. So we can therefore say let p be equal to 2. That means wherever I see 2, I'm going to be replacing that with p. So the expression on the left becomes the square root of p minus the square root of p plus x equal to x. Now let's get rid of this radical by taking the square of both sides. So I'll take the square on the left, I also take the square on the right. Now notice that the square can cancel off the square root, so that I have p minus the square root of p plus x equal to x squared. Our next step will be to move this x squared to the left hand side, so that I have p. As x squared crosses to the left, it becomes minus x squared equal to, I'm going to be moving this negative square root of p plus x to the right, so that it becomes positive here on the right. Now let's get rid of this radical here by also taking the square of both sides. So when I take the square of both sides, you notice I'm going to be having p squared minus 2px squared plus x to the power 4. That's what I have on the left hand side, equal to, then on the right hand side, the square can cancel off the square root, leaving behind p plus x. Now let's move everything on the right to the left hand side. I'm going to be having p squared minus 2px squared plus x to the power 4. And as p crosses to the left, I'm going to be having minus p. And as x crosses to the left, I'm going to be having negative x equal to 0. I want to write this expression on the left as a quadratic equation of p. And before I do that, I need to arrange this expression. Let's rearrange this expression. We have p squared. I'll do that by arranging the terms with p first. So minus 2px squared negative p before writing the terms with x. Are you seeing that? Very good. So our next step will be to factorize out the p here, so that I have p squared minus 2x squared plus 1. Now factorizing out p. Now plus x to the power 4 minus x equal to 0. Now notice that I have a quadratic equation in p here on the left hand side. So simply saying that a is equal to 1, since I'm going to be using the general formula, and b is equal to negative 2x squared plus 1, and c will be equal to the remaining terms, which is x to the power 4 minus x. Now this is the quadratic formula we're going to be using. P is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. So we're going to be substituting each of these terms here on our quadratic formula. So let's do that real quick. So substituting, I'm going to be having p to be equal to negative b. Now negative b, I have negative here, I have negative here. So when they both come together, I'm going to be having positive of 2x squared plus 1. Now I'm going to be writing plus or minus the square root of, remember this is b squared, but b is carrying a negative sign. But whatever I am taking the square of will be a positive. So there's no need writing the negative along with it. So I'm just going to be writing 2x squared plus 1 squared. Because even when I write negative, I'm going to be having the same result. So minus 4 times a times c. 4 times a is 1. So 4 times 1 is 4 times c is x to the power 4 minus x all over 2 times a, that means 2 times 1, that is 2. So our p will be equal to 2x squared plus 1 plus or minus the square root. So I'm going to be opening up this bracket. And how do I do that? I have 4x to the power 4 plus 4x squared plus 1. When I open up this bracket, that means expanding this. So minus 4x to the power 4 plus 4x. So this is what I have by simplifying what I have inside the radical. So all over 2. Now p now is now equal to 2x squared plus 1 plus or minus the square root. Now notice that 4x to the power 4 minus 4x to the power 4 is gone because it is 0. So I now have 4x to the power 2 minus, okay, that's plus 4x plus 1 all over 2. Now notice that what I have here inside of this radical is a perfect square. That means it can be written as p equal to 2x squared plus 1 plus or minus the square root of, now remember I said this is a perfect square, which is 2x plus 1 raised to the power 2. So 2x plus 1 raised to the power 2 gives 4x squared plus 4x plus 1. So all over 2. Now notice that this square can cancel off the square roots, so that I have p to be equal to 2x squared plus 1 plus or minus 2x plus 1 all over 2. I'm going to be putting this in parentheses so that it looks good. So let's move forward. So this becomes p equal to 2x squared plus 1. I'm going to be taking the plus first, plus 2x plus 1 divided by 2. Or p, let me take the one of negative, is equal to 2x squared plus 1 minus 2x plus 1 all over 2. Now let's deal with this one of positive first. So you notice that I'm going to be having p to be equal to 2x squared plus 2x plus 2 divided by 2. And this can be factorized out. So let's bring out 2 because 2 is common. So when I factorize 2 out, I'm going to be having x squared plus x plus 1 divided by 2. Now notice that these 2 can cancel off this 2, so that p becomes x squared plus x plus 1. Now let's focus on this other one. I'm going to be having p to be equal to 2x squared plus 1. Now use this negative to open up the bracket so that we have negative 2x negative 1 all over 2. So p here will be equal to, now notice that plus 1 minus 1 is gone and 2 is common. So let's bring out a 2, leaving behind x squared minus x. So x squared minus x all over 2. And 2 can go off with 2. So p will be equal to x squared minus x. Now remember that p is equal to 2. P is equal to 2. So we're going to be replacing the value of p here, which is 2, in each of these equations. So now substituting 2 for p, so we have 2 equal to x squared plus x plus 1. I'm going to be moving this 2 to the right hand side. I already have x squared plus x here plus 1, and as 2 crosses it becomes minus 2 equal to 0. So this becomes x squared plus x, 1 minus 2, that's minus 1, equal to 0. So now let's use the quadratic formula to solve this. We have x to be equal to minus b. B is 1 plus or minus the square root of b squared, that's 1 square. 1 square is 1, minus 4ac. 4ac, that's 4 times 1 times negative 1, that's negative 4. So negative 4 times this negative here gives plus 4 all over 2a, 2 times 1, that's 2. So x here will be equal to negative 1 plus or minus the square root of 5 all over 2. Now let's face this other one. I'm going to be substituting 2 for p here. So 2 is equal to x squared minus x. Moving this 2 to the right hand side, I'm going to be having x squared minus x. And as 2 crosses, it becomes minus 2 equal to 0. Now let's also use the quadratic formula. So x here will be equal to negative b. Negative b is already negative here, so rendering this to be positive. So which is going to be 1 plus or minus the square root of b squared. B squared as negative 1 squared is 1 minus 4ac. 4 times 1 times negative 2, that's negative 8. So that means I'm going to be negative times this plus negative here gives plus. So 8 all over 2 times a, that is 2 times 1, I'm going to be having 2. So x here will be equal to 1 plus or minus the square root of 9 over 2, which can further be written as 1 plus or minus square root of 9 is 3 all over 2. And this x is equal to, let's go with the one for plus first. So 1 plus 3, that's 4 over 2. So the value for x is 2 here for the one of plus, or the one of negative, I'm going to be having 1 minus 3, that's negative 2, divided by 2, x will be equal to negative 1. So we have 4 values for x here. We have these 2 values for x here, and we also have other 2 values for x here. But which are the ones we're going to be accepting? When you take a look at our original question, you notice that this expression on the left, which is the square root, is equal to x. It means that x is always going to be positive. So that means we're going to be neglecting the negative values of x. So we're going to be sticking to just the positive values for x. So the values for x we're sticking with is x equal to, I'm going to be picking the positive, which is negative 1 plus the square root of 5 over 2, and the value of x equal to 2. So x equal to 2. So let's check to see which of these is the real value for x. So let's check. When x is equal to 2, so remember our original equation is the square root of 2 minus the square root of 2 plus x. This is equal to x. So we are checking for when x is 2 to see if we're going to be having the same value for 2. So let's do that. On the left hand side, we have 2 minus the square root of 2 plus x is 2. So 2 plus 2 is 4. So the square root of 4 is 2. That means I'm going to be having 2 minus 2, which is 0. So this is not a solution for x. So let's check for when x is equal to the second solution, which is negative 1 plus the square root of 5 over 2. So I'm going to be substituting that here. So I have the square root of 2 minus the square root of 2 plus x. Remember, x is negative 1. So if I have negative 1 here, so I'm going to be removing this minus because it will be affected by minus 1 minus the square root of 5 over 2. So this becomes 2 minus the square root of 2 times 2, that's 4. 4 minus 1, that's 3, minus the square root of 5 over 2. Well, I can simplify this expression to be the square root of 2 minus by multiplying both the numerator and denominator by 2. So when I multiply the numerator by 2, I'm going to be having 6 minus 2 root 5 all over 4. And this expression can be simplified into the square root of 2 minus, I'm going to be having the square root of 5 plus 1 all over 2. So we're going to be solving this in the next slide. Let's go forward. So I can go ahead and put a bracket here so that I don't get confused. So I have the square root of 2 minus the square root of 5 minus 1 all over 2. So 2 times 2, I'm going to be having 4. So 4 minus 1, that's 3, minus the square root of 5 over 2. So this is what I have. So in order to make this solvable or achievable, I need to multiply both sides, as in the numerator and the denominator, by 2. So I'm going to be having square root of 6 minus 2 root 5 all over 4, which can further be simplified as the square root of 5 minus 1 all over 2. Remember, this is the same thing as writing negative 1 plus the square root of 5 over 2. So this is a take. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.